Hi, and welcome to the next video. Rest assured, there will be algorithmic slander, but also something completely new, algorithmic appreciation. But to assuage your and my concerns about change, here's our security blanket of tradition.
I gotta tell you, it was perfect, down to the last minute details.
C99, now that's a standard. But before the video proper, if you're not interested in devlogs, please make a suggestion for anything else in the comments. I'm quickly going over a lot of stuff in this video, so if you want to know something more about anything I breeze over here, or just, again, something else entirely different, please let me know. So, how is the GDScript LSP going? It's going great. As we see here, it's fast. Here's my killer feature. Here we have Godot. There's mismatched leading white space. Simple question, where is it?
Here's a number. Psych! That's the wrong number!
Whereas if we look at my piece de resistance, we know exactly where it is. Now this may seem like a small thing to you, but this is the stuff that matters and why I had that classic American hold my beer moment. There are simply too many friction points with the built-in language server, and most painfully, it's slow. God, leading whitespace sensitivity is awful. What kind of idiot thinks it's a good idea? Enough showing off. I know I enticed too many of you last time with my 10 seconds of hate against abstract syntax trees. So, how am I doing things if I'm not generating an AST? I just shunt things around. Thanks, Dijkstra. You know, CS really peaked as a field with Dijkstra and Worth. When I quote-unquote locked in, realizing I had to basically make a compiler front end for this project, I did what I do best, steal other people's better ideas. That's how I found Chandler Carruth's great talks about the Carbon compiler's design. See the description for the specific video, but I really like all of his videos. They are all great and worth watching. But for those of you who don't want to click away, thank you by the way. The basic gestalt is that ASTs, and all trees for that matter, are just an open door for cache misses.
The mental hospital cannot stop me.
Otherwise, manual memory management is easy. If you call free, you're a bitch, play Mallet Golf, and arenas get you 95% of the way there.
Government cannot stop me.
Oh god, where was I? Chandler, Carbon. Anyways, what they're doing in Carbon is just shunting tokens around and parsing that. Dijkstra got it right. Just shunt the tokens into whatever order you need, and as an added bonus, I know that there will be at most the number of tokens I started with. So I can just allocate a single thick slice of memory once and not have to worry about it ever again. Carbon shunts them into reverse order traversal, i.e. the leaves of the tree come first and the root is last, and I basically do the same thing, but I have my expressions in mostly reverse Polish notation order, meaning arguments come before operators. I have to do some funky stuff for function calls, and I'm still waffling on ternaries, but it beats abstract syntax trees. As an added bonus, this means my parser is a push-down automaton, making it a step away from being a Turing machine, which gets funnier and funnier the more you think about it. And honestly, it's just easier to traverse an array than it is to traverse a tree. Plus, if someone complains about the order after shunting, I can simply answer, actually, you're drawing the tree the wrong way. And that's basically that. This is your reminder to read Fabian's data-oriented design book, since it should be immediately evident that an array is better for cache locality than a tree. Now, I'd like to say I have something that's actually usable, but not yet. And this is where I think this might be harder than dealing with an actual programming language instead of some goofy dynamic scripting language. For GDScript to be a proper language, like C, I'd be able to parse the included headers for function declarations, etc. But where does Godot declare the update function for nodes? For those of you who haven't taken a gander at the Godot source code, during the boot process, all of the classes, enums, etc. get added to their respective databases. So while the built-in LSP can look at a function and tell you when you fucked up the arguments, I have to build my own damn API database. Later versions of Godot are good enough to export its entire API into a JSON file, and I have a JSON parser. hammer meet nail. Now, one of my goals for when I do release the binary is that I want it to be an honest to God standalone binary, meaning I refuse to ship this file as well. So I had two options. Bake the JSON into the binary, real easy, but it is 9.5 megabytes, and I don't really want all that just sitting there on the stack if I only need it at boot, or parse it and create code to create the database. Now, obviously, you know me, I went with the latter option. How could I refuse old school code gen? Gemini. Fuck Gemini. This is how the Greybeards generated code back before ChatGPT. Look at this. That ain't the limerick. If these large language models don't got the brains or the balls to finish the limerick, I don't want to put in a single character in any codebase of mine. This is also one of my many arguments for makefiles over all other goofy ass build systems. CI/CD? This is my CI/CD. Can you compile and run a program to generate code that then gets compiled into another program with CMake? Probably. But is it as easy as this? Fuck no. But speaking of parsing JSON, I also wrote another JSON parser that makes this number 3. This new parser is completely justifiable, however. The API file and all LSP client messages are perfect JSON, so I don't have to do any linting or checking anything. I can just read. And if they're not perfect, I can just bitch at someone else to fix their code. That lets me basically just tokenize the JSON, then just read it from first token to the last. Now, some of you are probably sensibly wondering why I didn't write a Python script to do this. Two things. Number one, I made a resolution recently to never write another Python script. From now on, I will use Common Lisp for all of my scripting. And two, I have to deal with LSP messages anyways, so I took this as an exercise to improve the ergonomics of this new JSON parsing codebase. So I got my JSON file, I got my fancy new parser. How's it all going? Well, the generated file is 60,000 lines, but only 3 megabytes. And 3 is less than 9. Admittedly, it's mostly just quick little macros each line. As an aside, yes, you should learn how to use macros. They make code gen super easy. But I'm not done yet. There are still a lot of keys I'm not processing, but my excuse now.
I will simply continue to be silly until the end of my days.
When I do wake up first thing in the morning, I'm just hobbling like an old man. Also, during one of my short 5-mile runs, I had a fun idea for how to allocate scratch memory. And yes, I think while I run, Murakami writes about this. So how I'm doing things at the moment is I just have an array of arenas that I can use for whatever I want. It's scratch memory, baby. My only complaint is I only get 16 of these bad boys. Now, it is trivial to just increase 16 to whatever, but this is my codebase and I demand comedy. Check out this beauty. As you can see, it's hilarious. I love it. I can allocate endless scratch arenas. It's basically a linked list, and don't at me, linked lists have their place, and it's right here, baby. But I'm using the size member of the arena struct to store the relative offset to the next arena. That is to say, it's a relative pointer. So I can yeet any old mallocked arena into it so I can reuse it later. And since it's a 4-bit signed integer, that means there's now a system requirement of 2 terabytes of RAM or less. Hilarious. This code gives me just so much joy, but I don't know if I should use it because look at this in my original Scratch allocator. Check in all. I love that. It is so practical. My master plan for when I finally get to the actual language server protocol part of this Herculean endeavor is to just call that bad boy at the start of every iteration. 0 memory leaks. This devious code doesn't have that. Now, obviously, there is a Hegelian synthesis between my regular practical Scratch allocator and my devious, hilarious Scratch allocator, but I did some light attempts at implementing it, but I'd have to create a whole new struct, and no matter the size of these scratch arenas is gonna go up from 16 bytes to 24 bytes, meaning I'm just gonna have a whole extra bytes there, which unfortunately means there won't be any more need for relative pointers. I tried it out. The laughter would end. Oh, and attention, I have finally implemented a hash map. Turns out it's super easy. I'm using Murmur 3 to hash at the moment. Praise be. And I should probably use this during token identification when I lex as well, and ideally I'll shave off some time. I'll test it out, and if it's faster, I'll keep it. Otherwise, the macros stay in during tokenization. Remember 3 is probably overkill for token ID, so I'll just use the simplest hashing function I can find that avalanches well. Little trick to reduce collisions: make your hash map 4 times larger than the number of things you expect to store in it. I think I heard this during the interview with Stuart Lynch, the creator of the 10x editor on the Woocash podcast. And I just scrolled it away deep within the cobwebbed crannies of my brain. Or I might be imagining all of this and spreading based misinformation. 50-50 really. Anyways, the link to that interview is in the description, so go ahead and fact check me, please. It's a good interview regardless. I'm a big fan of the Woocash podcast, especially when it's a technically focused episode. I'm also making my hash maps be power of 2 sized, so I can use bitwise and instead of modulo. This is probably overboard. And that's it for the video. As always, thank you for watching. I appreciate your time, and I hope you had a good day. If you liked the video, please give it a like and subscribe for whatever comes next. The next video will be out within a week of this one, since it's going to be an update of an already existing video. Hopefully I just have to quickly add in some additional bits to the start of it, but other than that, a re-release, which I feel like it should have gotten more traction when I first put it out. But after that, again, comments are open for video suggestions and whatever else you feel like commenting. I would like to say I read all your comments, and I really do try, but the studio backend is not the best, so if I missed you last time, my apologies, but I really try to read all your comments, but YouTube Studio leaves some things to be desired on that end. Oh, there's also a Discord server for the channel where you're also more than welcome to make video suggestions, along with talking about memes, programming, game dev, and baking. And speaking of baking, let's get to it. Well, what do we have here? Looks like burnt focaccia, and you know, I'm always kind of in a weird spot with focaccia. I know I really have to blast it with heat to get a good oven spring, but you know, especially with this, I make such big focaccias. This probably wouldn't happen if I used just what I use for my sourdough, but what can I say? I love making huge loaves of focaccia like this. So I blasted it with heat, and I guess this time just too hot, and it got a little burnt. But as you can see, I got some nice cherry tomatoes on there. Love the flavor, especially when they're roasted like this. So honestly, yeah, I got a little burnt, but still delicious. And of course, black pepper, and I always put a touch of salt on my focaccia, and you know, that's that. But you know, it's not the complete end of the world, because if we look at the cross section, you know, I blasted with the heat to get a nice cross section, and would you look at that, I indeed got a pretty good oven spring on this. And looking at the crumb, I would say that this might be, I'm gonna go with either 80. Yeah, this looks like an 85% hydration. I didn't write down the hydration notes on this one because I was just simply too distraught. But and look at that nice, real open crumb structure. Looks almost spongy. That's what you like. And again, you know, but other than that, and you know, I also of course add a bit of whole wheat to all of my loaves for a bit of extra flavor. But other than that, I can't really say much about my focaccia. But I guess, I don't know, maybe this time I probably just forgot to tent it, or actually what's more likely is I forgot to turn down the heat, because what I usually do is I tent it with or cover it with aluminum foil for like 10-15 minutes, just to keep the steam in there so it can really rise, and then for the last 20 minutes I uncover it and let the top, you know, crisp up. Otherwise you get a real soggy top. You don't want like that. I guess here I forgot to turn it down after I uncovered it, which, you know, oh well, it's unfortunate, but it happens. And nonetheless, it was delicious, nonetheless, especially with the cherry tomatoes. Cherry tomatoes, they're so sweet and delicious. Yeah, so that's the baking segment for this week. Not much to say since I forgot my hydration notes, but again, focaccia, again, something super easy, especially, you know, I often make it in I have a good carbon steel pan that I just use for everything. And I make focaccia in there too. Turns out great. And you get all the you get the delicious flavor from everything I cooked in it whenever I do that. I think that's quickly becoming my favorite way to do focaccia, especially because this one I also have a stainless steel baking tray. Oh my god. And no matter how much oil I use in it, like I'll deep fry the focaccia, but still it will stick to the tray. Not as good as carbon steel. Big carbon steel fan. But yeah, I'm going to use the classic sign-off with guilt-free, because this does have yeast in it. The yeast in the air is free, so go out there and bake. It's nutritious, it's delicious, and it's good for you. It's good for the soul, and it makes a great gift. It's a great way to show, and the gift is baking, not the yeast, just to clarify that. And it's a great way to show people that you appreciate them. And I appreciate all of you. So thank you for watching, and I will see you next time.